Good morning. So, computers, what's the deal with them? They're like everywhere and everyone uses them. Chances are you're actually watching this video on a computer of some sorts right now. You know what? Actually, it'd be kind of weird if you weren't. Honey, the new JPEG video's on cable tonight. Ooh, coming, dearie. Yeah, that'd be a little bit weird. Anyway, so computers are everywhere. I have one in my pocket. I'm wearing one on my wrist and I'm actually talking to you through one. But do we ever stop to think how computers actually work? What type of magic flows through those wires? If you're looking for a simple answer, then there's zeros and ones, where 0 is off and 1 is electricity on, all going through series of logic gates. But it can be pretty hard to visualize how these supposed zeros and ones can turn into my anime girl background. So let's build our own computer. What's going to be the most annoying thing I could build it out of? How about marbles? Also, CodeBulla, I'm taking direct inspiration from you, so please don't sue me. Okay, so let's set some ground rules for what I'm going to make here. First off, I'm going to make this all in real life. No digital simulations, unlike a certain video with 2.7 million views. Next up, due to size constraints, I'm going to make this calculator do only one operation, and I chose multiplication for that just because it would be cooler than addition and it wouldn't be crazy hard. So now I have my goals, let's actually do this. I looked up a simple circuit design and this is what I'm going to make. For those of you who aren't nerdy enough to already know this, but this right here is an AND gate, which means if it has both of its inputs as true, or in this case, both marbles, then it should output something. But if it doesn't have both of them, then it won't. The other logical operation in this is an Xor gate, or exclusive OR gate. This is slightly more complicated. If it has one input or the other, then it should output, but not both. No clue how I'm going to do this, but that's a problem for later me. Let's get started. Okay, I'm ready to start working. So this is the circuit diagram I'm going to use. So it's only made out of AND gates and XOR gates. So first, I think I'm going to start with trying to get a design of a AND gate working, and then I'll move on to maybe a splitter or an XOR gate. So I'll catch with you later. Living off a prayer and not fully understanding what I was getting into, I started by designing the AND gate. My thought was getting each gate working in final isolation, then putting them all together in the final calculator. Okay, this is my first draft, so let's see how well it goes. Oh, come on. So the first one gets stuck in there, and the second one goes out. Boom! We did it. Clearly, I had some work to do. Okay, I've refined the design a little bit, so now it's more consistent and it's all set at angle. So I think I'm going to leave this for a bit. It's hard to know. I can tune it much more, but it's hard to know without knowing what other components need, like how steep to make everything. So I think I'm just going to try and make either the XOR gate or the splitter gate. So we'll see what happens. With that done, I finished up for the night, but I was up early the next morning, eager to continue working. Okay, it's the next morning and I've done quite a bit of process. So first of all, I kind of redesigned the AND gate, so it's the same concept, but it's just smaller, so this gets stuck in there, second ball goes over it. I made a splitter, which ball just drops down, knocks those off. I don't have to show you those. But this is what I've been working on lately, and this is the XOR gate. So it outputs one if it's one or the other, but not both of the inputs. So this one was really hard, but I'm pretty happy with it. So I put in one marble, and it spits out the end, so that's all good. Let's reset it. And now I'm going to try and putting in two marbles. And if I put in two marbles, it shouldn't output anything. So put in the first marble, put in the second marble, and boom, it works. I'm so happy. Okay, I'll catch you guys later when I have another update. After this, I thought I was done with all the hard parts. Everything was designed, so it should just be as easy as putting them all together. Right? Right? Okay, I got all the components ready now. I'm just gonna try and lay this out. So we'll see how it goes. I started doing this, realized it was way too hard, so I drew out a diagram and now I gotta put it in bricks. The diagram I drew for the circuit came in very handy, and I continued to draw and to expand this diagram as I went along. After this, I went heads down mode and started working like crazy. It wasn't easy work at all. It was long, grueling, and painful, especially for my knees. I expanded my design to take up more and more of the logic gates, eventually getting to my solution. Okay, I think I finally got a design working. So this is all the gates. It works. I'm not going to show you now because it's just so unreliable, but I'm going to redesign it. I have this extra base actually I made for something different. So I'm just going to reuse that base, redesign this. I was talking to my brother. There's a couple of redesigns that I already know I'm going to do, but this is a proof of concept. I got to make the final thing. Yay! Now comes the hard work. After hours of blood, sweat, and tears making this prototype, I now have to convert it into its final design. That also hopefully looks better than this monstrosity. I started redesigning everything. I made this design considerably more compact and at least tried to make it more reliable. The splitters were one big area that I tried to rework. See, in the original circuit diagram, all of these points, the wires split, but I can't exactly split a marble, so I need to start another marble that goes on an alternate path. I had a couple of designs, but in the end, I ended up using a lot of these levers and push rods to make everything work. Well, let's get to work. Hyper time-lapse mode activated. Okay guys, this is my marble calculator. So up here we have the inputs. So there's two 2-bit inputs. This is the first input, this is the second, and down at the bottom we got our 4-bit output. So why not get a test? I got it all primed and loaded. Right here I have my random number generator. I don't know if you can see that, but I'm screen recording so it doesn't matter. So we're going to generate a number from 0 through 3, because that's all the numbers you can do with 2 bits. You can do 0, 1, 2, and 3. Okay, our first number is 2. So 2 times 1. Okay, so we're going to put 2 in this input, and 2 in binary is represented by 1, 0. So we'll put a 1 in this slot, and we'll leave this slot 0, and then 1 in binary is represented by 0, 1, so in this input we'll do 0, 1. Now I'll put you guys down while I pray that it works. Oh, that fell off. That's supposed to go right there. Okay, time for the moment of truth. And there you go, folks. Here's our output, 0, 0, 1, 0. If you convert that to binary, that is 2. Ta-da! Okay, guys, so this is my calculator. I sure hope you liked it, because it was a pain in the butt to make. Well, here's the final thing. In the end, it still wasn't that reliable, but I guess that it actually looks pretty cool, and it's a simple calculator. In the end, hey, at least I can say I actually made it in real life. Code bullet. I know that this isn't really reliable, but it's less of it being useful and more of an interesting model of how modern computers work. In the core, these are the logic circuits that make our computers run. Thanks for watching. Believe it or not, this is completely sidetracked. I'm actually gearing up to release my first game on Steam and mobile, and that's going to be the frog game I've worked on. So keep your eyes open for the next couple of days and I'll post something, maybe even the game. I have a bit more of work and approvals to get all sorted out, but then I'll put a demo version for you all to play. If you like this video, then like and subscribe. If you didn't, don't, or whatever. I'm not your mom. Thanks for watching, and I'll see you guys next time. Ugh, now I have to clean up this mess. Yippee.